The first flight of the Gemini program, Gemini 1, had proven the Titan II booster as capable of hauling a manned spacecraft. But more was necessary to prove the Gemini capsule was safe to carry a crew. Namely, the heat shield needed further testing. On Gemini 1, the spacecraft was designed to be destroyed on re-entry. The heat shield had holes drilled within the base, allowing superheated air to tear the capsule apart from the inside. Unlike the test article that was the Gemini 1 capsule, the Gemini 2 capsule would be much more similar to the one used for crewed flights. It would contain ballast and equipment to simulate a crew aboard. Gemini 2 would be a suborbital flight, similar in nature to the Mercury Redstone flights. The capsule would be in space for just a brief few minutes before performing a ballistic re-entry.
Men advised to stand by for the terminal count. 10, 8, 7, 6, 4, 3, 2, 1, 0. Liftoff. 5.
The flight of Gemini 2 was a complete success. The capsule returned safely, proving the effectiveness of the heat shield for a crew passing through the atmosphere. But this was not the end of the road for the Gemini 2 capsule. To understand what happened next, we must shift focus from the NASA Gemini program to its military-based sister program, the Manned Orbiting Laboratory. One of the many planned Gemini spin-off programs, and spearheaded by the Air Force, the Manned Orbiting Laboratory was, in essence, a series of military space stations. They were designed for reconnaissance, carrying both experiments and a telescope, to be used by military astronauts to gather intelligence beyond what could be captured with spy planes, balloons, and other terrestrial means. To maximize intelligence gathering, the stations would be launched into a polar orbit. This would allow for greater coverage of the Earth's surface, and is the orbit that many weather and Earth mapping satellites have opted for. A significant change between the NASA Gemini program and the Manned Orbiting Laboratory would of course be the small space station affixed to the back of the spacecraft. Not only would it require a more powerful launch vehicle than the Gemini's Titan II, it would also require modifications to the Gemini capsule itself. The Air Force planned to have astronauts enter the station without performing a spacewalk. For this to be accomplished, they would need to pass through the base of the capsule, where the heat shield sat. A hatch would need to be cut into the heat shield. Further modifications also needed to be added to the crew area within the capsule to allow astronauts to maneuver themselves out of their couches and into the station. Understandably, there were concerns about the safety of cutting a hole in the heat shield. While the hatch would be closed for crew re-entry, any flaws in the thermal protection system introduced risk to the crew. If the hatch were misaligned even slightly upon closing, re-entry would mirror the deliberate destruction of Gemini 1, tearing the capsule apart from the inside. The concept would need to be tested, and the Gemini 2 capsule was just the spacecraft for the job. It had returned in good condition and could be modified to fit the needs of the Air Force. It had already performed its primary mission, and its loss would be of little consequence. In preparation for the mission, the spacecraft would have to be modified. Filled with instrumentation and with a hatch cut into the base of the spacecraft, Gemini 2 was ready for a second flight. It would be the first man-rated capsule to be reflown in space. The second launch of the Gemini 2 spacecraft would not be aboard a Titan II. Instead, it would be aboard its larger younger brother, the Titan IIIC. With two strap-on solid rocket boosters, the 3C packed enough of a punch to carry almost 30,000 pounds to orbit. It was built to support the ill-fated Dinosaur program, a military spaceplane project that was canceled before the Titan IIIC even took flight. Aspects from Dinosaur research would make their way into other spaceplane programs, including both Shuttle and the X-37B. Despite experiencing a number of failures, the 3C would be used for primarily military launches from 1965 up through 1982. The launch of the Gemini spacecraft aboard the Titan IIIC would also include a mock-up of the laboratory itself. The flight would be another suborbital flight for the spacecraft, testing the capabilities of the Titan IIIC to support manned spaceflight, the laboratory mock-up, and the ability of the capsule to survive re-entry. Incredibly, it did. On November 3, 1966, the first and only launch of the Manned Orbiting Laboratory program took flight, and the Gemini II capsule would make a ballistic re-entry. Despite the hatch carved into the heat shield, the spacecraft survived re-entry. It was the first capsule to be successfully flown twice, and was the only American spacecraft to be reused until the Space Shuttle program. A truly unique spacecraft, it speaks to the quality of Gemini engineering and the versatility of the Gemini spacecraft itself. Though the Titan IIIC would be man-rated, it would never fly a crew. The Manned Orbiting Laboratory was canceled on June 10, 1969, just a little over a month before Apollo 11 would land on the Moon. While many of the spin-offs from the Gemini program were canceled, the potential found its way into many other programs. A number of astronauts who had been selected for Manned Orbiting Laboratory were invited to join NASA's astronaut corps, with 7 going on to fly the space shuttle.